Assalamualaikum warahmatullahi taala wabarakatuh. My name is Ahmad Akmal Idris. I'm from Faculty of Engineering Technology, Department of Mechanical Engineering Technology. My SM title is Improving the Design of Body Temperature Scanner using Design for Manufacturing and Assembly, or Dfma. My supervisor name is Dr. Azli bin Nawawi. Okay, the first one we go to the website. Every industry needs to manufacture low cost, high quality, and quicker time on the market. Design for manufacturing and assembly is a methodology that can be used to reduce or redesign many products in the manufacturing sector. The benefit of FMA is that it can reduce the manufacture cost. The major purpose of this study is to propose a new design of body temperature scanner. Besides that, the manufacture cost, assembly time, and design efficiency are analyzing in order to support the modification. The analysis were carried out by disassembling the body temperature scanner, the operation of each component, and 3D modeling using SolidWorks software. And lastly, the DFMA design guidelines are used to create a new design. The selection criteria for a successful design are based on the cost of manufacture and the time of assembly. Finally, the design chosen has been proven to meet all the relevant requirements by improving in the operation cost, operation time, and design efficiency. The existing product design efficiency is 43.9%, and the new design is 78.2%. The operation time for the operation time for new design also improved from 68 to 29 second per unit to 54.51 second per unit. In this study, the overall operation cost reduction is RM 30 ringgit and 51 cent per unit, which is RM 27 and 31 cent, reduced to 30 ringgit and 80 cent. The percentage reduction is 45 and 5%. Okay, next we go to the introduction. Design for manufacturing and assembly, or DFMA, is one design process that focuses on developing a product which is to manufacture and assembly. DFMA is used to identify and eliminate waste of inefficiency in product design. DFMA combines two methodology: design for manufacture, which refer to the design of piece that will create a product for ease of manufacture, and design for assembly, which refer to the design of the product for simplicity of assembly. This design process was presented by Peter Durhus and Geoffrey Buttiot. Therefore, when designing a new product, the FMA will be utilized at the beginning phase of the venture configuration to characterize the prerequisites that the item will satisfy. The third one is literature review. Okay, as I mentioned before, Woodshot is one of the person who found the DFMA method around 2010. The DFMA method is a well-established technique for improving the efficiency of the product, leading to minimize cost of production. It also shortened the time of development product by reducing the number of components in the product. Next, we go to the Daily Isola in 2021 about body temperature scanner. Body temperature scanner were employed to measure pupils' temperature and refuse them admission to probable transmission area if they show sign of fever when the COVID-19 epidemic ravaged the world in 2020. In the United States, public health agency like as the FDA published standard to ensure that infrared thermometer or body temperature scanner are accurate and consistent. Next, we go to the methodology. Okay, the first one is we start. We identify product to improve. Then I disassemble product and study parts detail about the body temperature scanner. Evaluate the design efficiency of original design using DFA table. Then when result verified. If yes, I interpret result from the FA table for the original design. Then I propose product design modification. Then I evaluate the design efficiency of improved design using the FA table. Then I compare result between original and improved design using the FA table, and we can see the result. Then if the design improved, I construct visual representation of proposed modification. And the last one, I documentation and reporting the result in a table and also in a chart. Okay, next we can go to the result and discussion. We can see the difference between old design and new design in the table. Then the first one is total part. For the old design, we can see about 9 units of parts already in the old design. Then after we improve the design, the parts is decreased about 6 unit. The total reduction of the total parts is 33.3%. Second one is total operation time. For the old design, we can see the operation cost for each product is 98.29 second. For new design is 34 and then and 51 second. The total reduction for total operation time is 49.5%. Then next we go to the operation cost. The cost for one old design is about ringgit Malaysia 27 and 31 cent. The cost for the new design is 13 ringgit and 80 cent. The total reduction for the operation cost is 45.5%. The last one is design efficiency. For the old design, the design for efficiency is 48.9%, but for the new design is 78.2%. We can see here the difference between the old design is new design is quite a lot. New design is more better than the old design. From the table, from the chart below, we can see the operation cost and the operation time, the design efficiency. We can see here the new design is better than the old design. Okay, the last one is conclusion. The research primary purpose is to evaluate the current product and develop the design of the body temperature scanner using design for manufacture assembly process. The factors needed in this research include improving the quality of the product chosen, reducing the number of components and parts, and reducing the cost of the product. The DFA table is used in this research by contrasting the original and redesigned product. Overall, this product is much better than the original design due to cost and time saving of 45 and 5%. The operation cost for the original design is RM 13 and 51 cent, while the operation cost for the improvement design is RM 13 and 80 cent. This shows that the operation cost for the design improvement is much lower, with the difference in operation cost of the two is RM 30 ringgit and 51 cent. As a result, the data reveals efficiency of the original and revised product is about 43 and 9% and 78.2% respectively. All of these show that the research satisfy all of the objective outlined in Chapter 1. This analysis will serve as the foundation for future researchers seeking information on the current situation of the body temperature scanner.